So we split section 5.3 into 2 days. Day 1 was looking at kites. Today is looking at properties of trapezoids. So the warm-up is a kite warm-up. Find the other 2 angle measures in the kite below. So we learned yesterday in a kite that the non-vertex angles are congruent. So here's a non-vertex angle. Here's the other non-vertex angle. So this other angle is also 94 degrees. To get the missing angle, the other vertex angle, we know there's 360 degrees in any quadrilateral, and we're going to subtract the other 3 angles. And together that will be 82 degrees. So there's the other vertex angle. Okay, so trapezoid. What is it? What are the bases? What are the legs? Trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. So the bases are the parallel sides. Bases does not always mean bottom. So the bases are the parallel sides. And then the legs would then be the non-parallel sides. And the base angles are along the bases. So let's draw a picture to represent what this might look like. Let's do our parallel sides this way, for example. Oops. Okay, so let's label all the parts here then. The parallel sides are the bases. So here's a base. I'll call this base 2. I'll call this base 1. And then the other 2 are the non-parallel sides, or the legs. So I'll call this leg 1, leg 2. And the base angles are along the bases. So here's one set of base angles right here. The other set of base angles would be right here. Okay. Use the protractor to measure the angles of the trapezoid and find the sums. So if you measure these, you're going to find a couple, or a property here. Angle A and B, so here, angle A plus angle B. If you measure those and add them up, they end up equaling 180 degrees. And likewise, if you measure angles C and D and add them up, they end up being 180 degrees. So there's this thing called the trapezoid consecutive angles conjecture. Consecutive angles are the angles that are not the base angles. So consecutive means not the base angles. And we found that the consecutive angles between the bases of the trapezoid are supplementary. They add to 180. Okay, so these 2 angles add to 180, and these 2 angles add to 180. The base angles are B and C and A and D, so the consecutive angles are supplementary. So there's one property that we'll look at. There's another property. There's many properties of trapezoids. Use a protractor to measure the angles of this isosceles trapezoid. So an isosceles trapezoid is much like an isosceles triangle in which these 2 sides are the same in this isosceles trapezoid. You're going to measure, and you're going to discover a couple things here. The base angles of an isosceles trapezoid end up being congruent, or the same measure. So again, if we have this picture right here, if this is isosceles, this angle to this angle, and this angle is congruent to this angle. Okay, the next one, draw the diagonals above and measure them. So they're saying, all right, draw a diagonal. Okay, so if you measure those, they end up being congruent. So the next property, the isosceles, just an isosceles trapezoid, not any other type of trapezoid. The diagonals of an isosceles trapezoid are congruent, just like the base angles are congruent. Okay, let's talk about writing a proof for something like this. This is, as a group, write a flowchart proof that shows how the isosceles trapezoid diagonals conjecture follows logically from the isosceles trapezoid conjecture. Using the diagram at the right and a method for making the triangles easier to see. If you need help, see 232 example B. All right, so right here, the isosceles trapezoid conjecture says that the diagonals are congruent. Alright, so if the diagonals are congruent, I'm going to mark a couple things here. Well, I'm going to go this way. I'm going to say, alright, we're going to use the fact that these two angles are congruent and these two angles are congruent. Okay, and we're going to use, okay, and we're going to prove this. We're going to tell why the diagonals are congruent. So I've just marked the angles that are congruent. So what I'm going to do is I'm going to break this up into two triangles. So here are the triangles that I'm going to look at. I'm going to look at this first triangle right here. So I'm going to draw it right here. And then I'll look at the second triangle right here. Okay. I'm going to label them. This is P, T, let's see, A. And this triangle is R, A, P. And I'm going to mark what's congruent, what we already knew. We knew that this was the same. PT, this is the same. We knew that this angle T right here matched this angle right here. And we know that this angle down here matches this angle right here. Alright, so I've marked the two triangles that are congruent. And, oh, they share a side. Sorry, I shouldn't have marked these angles right here. I can only mark that they share the bottom side and this angle right here. Okay, so these two triangles are congruent by side angle side. And if they're the same exact triangle, then the diagonals are congruent, and the diagonals are TA and PR. So by CPCTC, the diagonals TA is congruent to PR. So here is just kind of like a paragraph proof explaining why the diagonals are congruent. And we just use side angle side. Okay, let's practice a couple problems here that you'll see similar ones on your assignment. Number 2, it's an isosceles trapezoid, and remember the properties. The base angles are congruent. So angle Y right here is also 56 degrees. Also in a trapezoid, we know the consecutive angles add to 180. So X right here is 180 minus 56. And so angle X will be 124. Okay, let's look at the next one. Number 3, let's look at the kite to begin with. We know that the non-vertex angles are congruent. We can figure out X by doing 360 minus all the other angles in the kite. And I believe that ends up being 64. Then in the trapezoid, it's an isosceles trapezoid. This is 137. And these two add to 180. So 180 minus 137 is 43 degrees. There we go. And we have number 5 right here. The perimeter is 220. Find the measure of PS. So we want this side right here. Okay, well, this length is 4x plus 1. So I know this length is also 4x plus 1. This is 4. This is also 2x minus 3. The perimeter is the distance around. So I'm going to add up all the x's around here. 2x, 4x, 4x, and 2x. And that will give us 12x. Then I'm going to add up all the 1s. So negative 3 plus 1 minus 3 plus 1 would be minus 4. Where's that plus 4? Let me think. Oh, I'm missing a side right here. This side is also 4 because it's isosceles. These match. So this would be plus 4. If we add up 4 plus 4 plus 1 plus 1 minus 3 minus 3. So that equals 220, the perimeter. And then we solve for x. So subtract 4 from each side. 12x equals, let's see, this would be, subtract 4. So that would be 216. And divide by 12. So x equals 18. And then to find PS, we would plug into 2x minus 3. So 2 times 18 minus 3 would give us 33. So there's the answer. And here's the assignment.